K is small. When something is small, that means it's something that is like 2 times 10 to the minus 7. Do you know what this number means? Like K is small. And if K is small, that means if I multiply it by any x, it's going to leave this much impact. Does that make sense? If you have a really small number and you want to multiply it by x and this number is like a really small number, is it going to make a big difference in that final answer? So I'm going to tell you that when you have numbers that are really small, you can actually eliminate one of the x's on the reactant side. I know, cool, right? Am I telling you this because I'm telling you the most precise way to do it? No, I'm actually telling you that you can make this shortcut, and it's a valid shortcut that everyone uses in chemistry when they see that K is very small. How do I know K is small? It's a minus 6, minus 7, and so on and so forth. If it's a minus 5 or minus 4 or minus 3, you might want to include it because it could make a difference if you exclude it. You can't just be like, I don't want it. You have to include it, okay? Jason's like, oh, I just got it, gone. No, you can't. Only if it's really small. And how do I define small? Times 10 to the minus 6 or 7 is small, right? What is that number? 0.000002. That's a very small number. So that number times x is going to have very little impact on my overall number. That's why you can exclude it, okay? So, number 4, if you notice, at a particular temperature, K equals 4 times 10 to the minus 7. Guess what? K is small, okay? So, if it's small, you can assume anything will be insignificant, so remove it from the equation on the reactant side. Reactant side, not product side. All right, so if I write this equation, N2O4, and I write NO2, that's the equation, okay? So it's very small, so I'm probably going to exclude the X on the reactant side because K is small, okay? If K is small, that means it's very little reactant, and I don't need to worry about it. All right, so what I'm going to do now is it says, in an experiment, 1 mole of N2O4 is in 10 liter solution. So first I have to actually take N2O4 and I got to take 1 mole and I got to divide it by 10. All right? So I can find its molarity, which is 0.1. Okay? So at a particular, at K, N2O4 in the experiment, N2O4 is placed in a 10 liter vessel. So I'm actually talking about my initial concentration, is that, right? So my initial concentration, this is Q, this is my initial. It told me I put 0.1 molarity of N2O4, which means that, which side is my minus side, guys? Reactant side, because I started out with this, so my change is minus X. This side is plus 2X. And what's this initial? Is it at 0? It starts out at 0, right? I put 0.1 molarity of N2O4, initial it's 0.1, initial of this guy, nothing. This is a minus X change because I started out with the initial. This is my plus 2X. Yes?
Wait, I know you just said it, but I don't understand why it's negative.
Because I know I started out with 0.1. What is an equilibrium expression doing? It's shifting from left to right, reacting to product. If I start out with something, what's the opposite starting out with? What's it going to do? It's got to lose it, right? Because it's got to take this to produce that, correct? If I start with something, I can't say I lost something I never had. Does that make sense? I have something, therefore I must lose it, so that this side can now gain something, correct? What's it going to gain? Plus 2x, okay? All right, so now, if I do my equilibrium expression, it's 0.1 minus x, and this one is 2x. So far, so good? All right, that's how we set up the expression. Yes?
So the other side of, like when you find your initial, the other side is always going to be 1, or no?
Unless it tells me otherwise. This equation told me I only had this.
So the one that has 0 is always going to be positive?
Yeah, because it has to be. Because if I start with something, I got to gain something. I can't start with something and then lose it.
Okay.
I never had anything. You can't lose something you never had. But I can lose something I had, correct? Does that make sense? Lost, gained. So it's not always reactants are minus. It's actually where your starting point is. And I know my starting point was N2O4 at 0.1. So that is why reactant was minus. It's not always reactant minus and product positive, right? It depends on the starting point. This was my initial concentration being started, okay? So now when I add these all up, it's, oh, I already did. 0.1 minus x and then 2x, all right? So now what I'm going to do is I'm actually just going to set the equation equal to that, okay? So I'm going to say, oh, by the way, what did I say about K being really small? What can I do to the reactant side? So guess what this side is? Just 0.1. Why? Because K is really small, so I can remove the x. I simplify my life, okay? All right, so that makes it a little bit simpler. Now I got 4.0 times 10 to the minus 7 is equal to my products, right, which is NO2, and I'm writing it out, squared, divided by N2O4. And I can plug NO2, and I can actually say this is 2x, right? And this side, right, is actually 0.1. Pretty cool? All right? So when I'm done, I'm going to have 4.0 times 10 to the minus 7 times 0.1, because I'm using algebra, equals, I'm going to move this down. 4.0, I need some new expos, times 0.1 equals, yeah, and this is what you guys got to be careful of. You know what everyone wants to call it? 2x squared. Was it really? The whole thing is being squared, right? Or people, most common mistake is telling me it's 2x squared. It's actually 4x squared, right? So this is equal to 4x squared. All right? What am I going to do to isolate the x squared? What am I going to do to isolate x squared? Divide it by 4, right? I'm going to divide it by 4. And I didn't give you the final answer, but you know it's x equals whatever this is, the square root of it, right? Why? Because it's x squared, correct? So that's why math is no fun, because that's where we get to.
Oh,
right?
Sure. Oh, that's easy.
For some of us, definitely. Right? Some of us, it's the sticking point. All right, so I get x is 1 times 10 to the minus 4. Okay? So now the equation was, at a particular k is this, in an experiment is placed, calculate the concentrations. Can you guys plug that in for x now? We know that, we know that the concentrations of the other one we can actually solve. Okay? All right, any questions on that? We okay? All right, go ahead and pause.